Flight 209er, you are cleared for takeoff.
Roger. Huh?
LA departure frequency 123.9er.
Roger. Huh? Request vector. Over. What?
Flight 209er, clear for vector 324.
We have clearance, Clarence. Roger, Roger. What's our vector, Victor?
Our radio clearance over.
That's Clarence over. Over. Roger. Huh?
Roger, over.
What? Hey. Who?
Welcome back to Fullerton College's Print 7577 Pre-Press Combined Lecture. This is your instructor, Ben Hewitt. Today we're going to start talking about illustration software, or how I learned to stop worrying and love the pen tool. We will be looking at the types of softwares that handle vector information. Let's jump right in and talk about what we're going to learn. We'll be taking a look at the difference between pixel and vector-based images, which is one of those things that if you only walk away from my class learning one or two things out of it and you forget the rest and it's all a blur, and perhaps I was completely ineffective at teaching you many, many things. One of the 2 or 3 things I really want you to come away from this with is a deep understanding of the difference between pixel-based and vector-based images. That knowledge alone can save your butt in printing. We'll look at the differences between sizing and outputting vector versus resolution-based images. And we'll look at some common software packages that might be a second video because this is a little bit on the long side of short. So let's jump right into one of the most important pieces of information of the entire class. Perhaps my entire department exists to teach you this one thing here. Pixel versus vector, the matchup of a century. So we talked about pixel-based images and raster images last time, and we looked at image editing software. And image editing software is all about changing the color of squares of color. That little grid pattern of squares, our pixels, makes up an image. Oftentimes it's taken from sensors of digital cameras or digital scanners. And depending on how many sensors you have and how many dots you're able to produce, you have a certain number of those squares per inch. Each one with its own value of light to dark and color information based on how much memory has been given to it by the computer program. And when your human eyeball looks at it, your human eye says, gee, look at all those different colors, they blend together, I think I'm seeing a picture. The computer sees it as a spreadsheet full of numbers. But in these things, each pixel square touches them in a grid. It's like a graph paper that's been colored in bit by bit by bit. No pun intended on the bit by bit. Meanwhile, here on the right, this D6 is a vector graphic. And vector graphics are interesting. Vector graphics use vectors to define objects. Sometimes it's called object-oriented. And I'd never heard about that, so I started teaching here, and some of our textbooks call it object-oriented. If you've done our one-on-one class, you know this. You're like, wait, what? Object-oriented? It makes sense. I know it is vector. They're both the same thing, but vector's the way most people talk about it. So a vector is a math term. And a vector is simply a line that starts somewhere and goes somewhere at a certain angle. So if you're talking about vector graphics, that means all the graphical elements are built out of lines. They have points at the beginnings and ends of the lines and lines that connect the points. Sometimes the points are straight or slanted, and sometimes they have complex curves applied to them, which we'll talk about a little more. And the complex curves applied to vector information is one of the most interesting things we're going to get to play with. I really like it. So anyways, what's really cool about vectors for printing, well, there's actually 2 things. The first one's covered by this chapter. The second one I'm going to mention, and if we're ever able to do things in person in the lab, we are going to play with to no end because it is my favorite thing to play with in all of our college's print lab. So first off, there is no pixel information in a vector object. The vector object is the shape that's been made, and it gets converted to machine pixels by the rip, which doesn't sound that exciting yet, but when you finish the whole double course of pre-press and you find out what machine pixels do and how they're calculated, you'll realize that this simple sentence means that vector will always print at the very best quality of the output device. So the same exact object, no matter how big or how small you make it, will look the best possible quality that anything can make. So if you take it onto a very, very, very precise output device, like a good plate maker, and it does 2,400 dots per inch and use a vector line in it, that means that your vector line will be described by 2,400 dots per inch. No matter what size you make it, that line will be precisely and perfectly shown in the output and the print. If you have a crummier printer, or even maybe not always crummy, large format's not bad. It's just not meant to be seen up close. It's meant for billboards, and you're going to see it from your car, hundreds of feet away, traveling, depending on the freeway, freeway speeds, whatever that means. On the 91, that means about 3 miles an hour. But still, you're still traveling past it at a long distance, and it's up in the air. So you don't need perfect image quality on a giant sign that you're driving by. That said, even if it only does 100 dots per inch on some of the big billboards, that vector line is going to be at 100 dots per inch. No matter what, the resolution is the output resolution. So it will always look as clear as possible by any output means. I don't know how I can make that sound cooler, but that is incredibly cool and incredibly good. That also means that the graphic can be made any size you want with no loss of quality, which is actually the second slide here. Apologies, but I get ahead of myself. I get so excited about this. So vectors are resolution independent. And that means that they do not need resolution. They do not have resolution.
I don't need anybody. I'm independent.
Yeah, me too. I'm whatever you said. Independent.
Every time I hear independent, I always say it in my head the way the cartoon reindeer says it. Independent. But it means you don't need anybody. And what that means here is vector does not need resolution. Vector exists outside resolution. Keep your resolution to yourself. We'll figure it out when we print. You can make these as big or as small as you want without losing quality. The exact same vector graphic can be used to make a business card and also be used to make a graphic that prints on a giant banner that hangs on the side of one of the full-size skyscrapers on Sunset Avenue in Hollywood. You can do the same graphic at any size you want, and it will always work as perfect as the output process. Illustrator programs. If you think that image editing in Photoshop are Kleenex versus facial tissue, my goodness, illustration software barely is different from the word Adobe Illustrator. Anyways, so the Illustrator tools that we're going to be using, there's 4 main categories I want you to know about here. I was talking about drawing tools, which are tools that create paths, normal selection tools, direct selection tools, and text tools. We'll look at those real quick here before we take a pause for our second half of the video. Sorry about that. The Roomba turned on and started to make a lot of noise, so I had to go turn them off. Anyways, so drawing tools, they make lines. They draw different ways. Some tools draw lines, like the pen tool draws between points. You lay down anchor points and you set the curve between the points. We'll be spending some time learning that today. We'll also be taking a look at the pencil tool. I don't like using it. The pencil tool is freehand. If you have a tablet, pencil tool can be useful. If you have just a mouse, or worse, good God, a trackball or trackpad, good luck. The pencil tool is going to be nuts because it involves a steady hand drawing the shape by itself. With a tablet type thing, you can make it, or a touch screen where you can draw directly on your image, you can make that work. But I have had nothing but problems with the pencil tool. That's just me. Maybe I'm just terrible. I could be. My skill is not in illustration, though I wish it was. Predefined shapes, circles, rectangles, stars sometimes, all sorts of things you can make that exist and are already built with constrained or less constrained proportions to make sure you get the right types of shapes. Because there's no reason you have to figure out how to draw a circle with a pen tool every time, because there's a circle tool to do that for you. And then all of these things create graphics. You can use straight lines, boxes, circles, curves, freeform paths, combine them together. Another one of my favorite tools in Illustrator, which we'll look at some point, is Pathfinder. Pathfinder lets 2 objects interact with each other. They can glue together, they can cut in half, you can use one of them as a cookie cutter against the other one. And I find I get really good illustration results using those things for making logos and graphics. Paths. Let's talk about paths. A path, or a line segment, a path is a continuous set of line segments that connect to each other. They start and end at points, although you can have multiple points in a path. You start at a point, you go to another point, and there's a line that connects the 2 points together. The first top picture is an open path because it doesn't connect back to where it starts. That's like a If any of you guys do hiking type things, that's like a there and back again hiking trail. You hike out, you hike back. You have to retrace your steps to get back to the beginning if you're hiking, but there's no way to return without going back over a previous set of footprints you left in the dirt there. But the second one is a closed path. A closed path means you've returned back to the original and the path is completely closed. If the path is closed, you can fill it with color. Now, updating this a few years, the latest versions of Illustrator will allow you to fill an open path as well. And just like that closed path has that top bar drawn across it and that makes it closed, if you use Illustrator now, the newest versions, 2020 version, you draw an open path, Illustrator will automatically draw an not invisible, it'll automatically close it off for you for the fill color. So that red would just have a white edge at the top instead of the blue line to actually keep it in. But that's how it works now. It didn't used to do that. That's a newer function. When I first started Illustrator, you did not do this. Although technically when I first started Illustrator, I did not understand it one little tiny bit. It wasn't on an old black and white Mac in the early days of desktop publishing, and being a 10-year-old child who had just learned how to use computers in general and was getting pretty good at Microsoft Paint. Don't judge me, it's a decent program, especially back in the 80s. MS Paint uses pixels. It's a raster image thing. It's an image editing program. Technically speaking, you can even touch up photos in there. Not very well, but you can do it. So when I tried to learn Illustrator, I'm like, well, illustration, painting, they're similar, right? Wrong. They are diametrically opposed in what they do and what they don't do. And it took me a long time to wrap my head around what Illustrator actually is. But understanding what it is and what it does will help you a lot. If you think it's going to work like paint, where you're going to draw a shape and so long as the shape feels closed, you'll be able to put color into it, it doesn't quite do that. It does it in different ways. By thinking in lines and vectors and points and starts and stops, it's quite different than thinking about paint strokes and squares of color that you've laid down, pixels, I mean. Last thing I'll stop on here, but we will pick up next time, is the Bezier Curve. The Bezier Curve is extremely exciting to me because of what it does and also because of what it does. First off, the Bezier Curve is based off of math from the famous French mathematician Bezier, because remember when you get into the hard sciences, the general rule is you name everything after yourself. That's why you get into science. You can name things after yourself. I have a weird last name. I probably should get into science just to inflict it on people. Anyways, so the Bezier Curve has a start point and end point, but also has other math to describe how the line bends between the 2 points. We use the pen tool to create this, and it can create some very good curves. I'm running out of time, so let me briefly say one of the things I like about it. So yes, you can use vector information to draw graphics that scale to any size, but the other half of what it does is you can take vector information and give it to a die cutting machine or other types of automation devices that follow paths. You can program a robot to walk in the path of a vector object. You can also ask robotic cutting machines like the one we have in our lab, the ESCO Kongsberg, to cut any shape you can draw with a vector. That's all the time I have for right now, but we'll be back.